this video, we are trying to learn the basic principles of the change detection in earthengine. The content is being adapted from the Spatial thoughts, and the links are in description. So the availability of Earth observation datasets at the regular intervals and over the longer period of time is useful for change detection. So there are different ways for that. So here 4 different methods have been listed. The first one is single band image, where the single band image or the spectral index are used with the threshold. And then there is the multiband change, where the spectral distance and spectral angle are used to find the changes. And then there is the classification of change, where the images are stacked containing different bands from before and after the event, and the detections are done. And then after we have the post classification comparison. Here we compare the 2 classified images and the transitions are computed. So in the single band, we use the spectral index. For instance, normalized bond ratio is the popular one. This is used for studying the bond vegetation areas. And what we do here is we compute the NBR for 2 different times, that is before and after, and we apply the suitable threshold to find the difference or to find the change. The second one is the multiband. Here we compute the spectral distance and spectral angle. In earthengine there is the function for that, and if there has been some larger changes, then there should have been some larger distance. So larger distance means there has been some changes, and this is suitable when no suitable indices are there. So in the classification of change, which is also called one-pass classification or direct multi-date classification, here we stack the images from different dates, and we train the classifier, and we apply the classifier on that stacked image to find the changed pixels. And finally we have the post classification, where we have 2 different images, and we try to detect what has been changed from what has been the change between 2 different classes. Here we use the function e.reducer.frequency histogram to understand the transitions. So let's begin with the first one here. So here in this particular example, we are using what has been done by the Spatial thoughts. So this particular example is from the 21st February 2019 and the 25th February 2019. So these are the 2 dates where the fire had occurred in those dates in the study area of somewhere in India. So this method can still be used to study the recent fire cases, such as in Spain, that's going on. And however, for this particular demonstration, we are adapting the materials from Spatial thoughts, and we are using what's there. So it begins with our area and the required dates. So here we have the geometry, and this is the polygon, and then after we have the start and end dates, e.date, 2 different dates, and we are centering the geometry at the zoom level 10, and here we have the image collection that is Sentinel-2. So there is the cloud masking function. We see this many times. So what we do here is we just mask the clouds from our analysis. So for that we work with the QA60, and we are masking those pixels which contains the clouds. And here in that function we are selecting the bands and we are preserving the time properties. So in that data set we want to have the images only from those area, and we map those function and we select the bands. So the second step now is to find the images from two different dates. So here we have here we are using the dot advance. So we want to go to the months before before the months that has occurred, so 2 months before. And also we have the advance here, so 1 month after the fire has occurred, so 2 different dates. So it depends on the selection of the dates what we want to see. And here is the visualization. So we are selecting band 12, band 8 and band 4. This particular false color visualization is used to see the greenness in the land surface, and the brown means your bare swell or it can be built up area. So this is for the Sentinel 2. So this is called the shortwave infrared band combination. So now we are adding the 2 different images, one before and one after the fire. Now here is the calculation of normalized bond ratio, and this is done exactly like how we calculate the NDVI. So the formula or the function is dot normalized difference. We select the 2 different bands, here band 8 and band 12, so that is NIR and SIIR. So, and we rename the band as NBR. So this is the function here, and we add this function to both of the image collection here, before and after, and we can apply them in the layer. So this is for pre-fire and this is for post-fire. So what we can do now is, after calculating the 2 different NBRs from 2 different dates, we can either subtract and see what has been the change. We can also apply the threshold, and here we have the threshold, and we want to find only those area which is greater than this value. So this depends on what the threshold will be, and this again can be added as the layer. So these are the 2 different ways for the visualization in the change detection. And there is another method for that as well. So there is this classification table as suggested by USGS, and what it does is we can group the values in many different bands. So for example, less than 0.10 will be considered as 0, and similarly from 0.1 to 0.27 will be considered as 1. So this goes on for 2, 3 and 4. So the method here is we are using dot where at the beginning, and we're using this operators LT, GT, and LT. So we are grouping, or we are let's say bisecting all those values in different groups, and so this appears as the band. So if we run this here, we find the different layers. So the first one here is the before image. So we can see here the greenness means the there is the presence of vegetation, and we can see here after, and we can certainly see that there has been some changes in this area. We can see the red patches here, and we had calculated the pre-fire NBR and post-fire NBR, and we had subtracted the 2 different NBRs, and there is the burned. So this was based on the threshold, and we can also see the severe. This is the layer which has now different bands in that, so we can use that to visualize. So this is the very first method where we are using the single band or the single spectral index to find the changes between two different dates. So this is the very first method. Now let's go on to the second method. So the second method is where we are considering the multiband image. So here we have again the geometry and our dataset, that is Sentinel-2, and here we have the visualization parameter. We are going to repeat the same process of writing the function for cloud masking. This is again the same, and we see this many times in the codes. So here we are applying that function. We want to have those images only from our area, and we're selecting the bands here. So again we have the date of incident, our interested dates, and here we have the before image. So this again goes back to 2 years back, and this one here is the 1 month ahead. So these are just the way in how we are selecting the dates. And here we are also applying the median at the end. So we add them as the layer, that is the before and the after image. So in this process there is this function called dot spectral distance. So as discussed before, we are calculating here the spectral distance between the two different images. So it starts with after dot spectral distance. So here we are using SAM. This stands for spectral angle mapper, and this calculates the result in the radians. So this is calculating the difference between after and before. So we are calculating the spectral distance, and this can also be done with the squared Euclidean distance. So this comes within the earthengine, and we can find the distance by calculating the square root of that distance. So we can add them as the layer. And finally, the thing that was done just like before is you can apply the threshold. So it depends on what we select, just by inspecting the different points and finding the suitable value. So again we apply the threshold and add that threshold image as the new layer. So we can run this. So we can see here the before image is this one, and after image is this one. So we can certainly see that there has been some changes. So this one here is the spectral angle, and here we have the spectral distance. So not exactly helpful at first, but as soon as we apply the threshold, it gets more clear that somewhere here there has been some changes in that time. So this is the second method of multiband, and we move to the third method, which is where we are applying the classification of change. So here we have the different data has been used. So here the first one is the boundary file, and the two different are the points to be used in the classification, and this one here is the Sentinel-2 dataset. So again we have the same repetition. We are centering the object, and we are here giving the visualization parameters. We're writing the function for the cloud masking again, and we are filtering the dataset here, applying the cloud masking function, and this one is for the 2019, and again from certain dates, we are doing this for the 2020. So these are the images of 2 different dates, and we can add them as layer. So we have done this by map.add layer for both of the dates, and we can add those 2 collections by .add band. So we are stacking the images, 2 different images in the single collection. So now we can apply that points on the image to get training data. So for this, we are writing this .sample regions. So our collections are that points we just saw. These 2 different are the points. So this will be used for the training, and we are merging the 2 different points, and the properties, this class is within those points. So this gives us the level, or this provides us the properties. So this is for training, and we now train the classifier. So here we are using ee.classifier.smile random forest. In earthengine there are other number of classifying or number of classifiers. So if we know more about this classification, we can certainly apply much more parameters. But here we are applying the simple one. We are providing this features as the training, and our class property is the class, and our input properties are the band names. So we can now classify the image. This is very simply done in a single line. Our interest image is this one, and we are classifying by .classify, and our classifier is classifier. Here the variable has been used. So this classifies the image. Now what it does, it creates the layer with the minimum and maximum value, and this shows the change between the 2 different images. So we can see there has been some red patches, and this certainly means the change between those images. So this was the 3rd method. So now we move to the 4th and last method. So here we have again the boundary, and here we have the different classes. The one is the urban, beer and water, and there are water and vegetation, so it contains different points. And here we have the data set. So again we repeat the same process. We have the centered, object centered, and here we have the visualizing parameter, and here we have the image for 2019, and we have here the images done with the median values, and we are clipping for our area of interest. Here we're adding that as the layer. So we are merging all those points by .merge. So there are 4 different classes, and that has been merged. And for the classification now, again we repeat the same. We have our collection, that is the training for the collection, and our land cover for the properties. So this land cover has already been inside those points while we are preparing those points, and we again train the classifier. So this is the same thing, ee.classifier.small random forest. We provide the training as the features. We have the class property here, and our different bands are used for the input properties. So now we can classify the image. So this is again done by .classify and providing the classifier. So we can add that as the layer. So this was done for the previous year, and we repeat the same process for the another year. So this here is for 2020, and we repeat the same process. So here we are again classifying that after image with classifiers. So we have here two different images being classified. So here we reclassify the values. It's just the remapping. It was 0, 1, 2, 3 as the class. This has been turned into 1, 2, 3, 4. This is the normal, just a way to reclassify the values. And we can now subtract between the two different classes, and it should not be equal to 0. If it is equal to 0, that means there has been no change. So we want to find only the changes. And here is the method to get the transitions. So what we do here is we multiply the before image with 100 and add the after image. So this results the pixel values to be unique and representing each unique transition. So 1 or 2 is urban to bear, 1 or 3 urban to water. So here we are multiplying by 100, adding the after classes and renaming it as the transitions. And we use the frequency histogram to get the pixel count. So this is done by ee.reducer.frequency histogram. We provide the geometry, we provide the maximum pixels, scales, and some tile scale. So these are different parameters. And so we can print the number of pixels for each class transition. So this is done by .get transitions. And we can also calculate the area of each class transition. So this is done by ee.image.pixel area. We divide with some numbers to convert it into square kilometers. We add the Morse bands, and here we are calculating the area, and this area is not easily retrievable, so we do some more course here. So for that we get that as the list, and from all these lines we get the number and area as list, which is converted into the dictionary by ee.dictionary here, and we can print the different transition classes. So let's run this and see. So basically, to summarize this again, so we are classifying two different images, before and after image, and what we do is we subtract before and after image. So after subtracting, there is a way, this is the particular way applied here. We are multiplying the before class by 100, and we are adding the after class. This gives us the transition, and then we use this frequency histogram to find the pixel count in each class, and after that we can print the area within the each transition. So this is the process here being done. So also for better understanding the change detection, we sure require much more study, I would say. So these are the 4 different methods. So again, to summarize, so we had the single band change, we had the multi-band change, we had the classification of change, and we had the post classification comparison. So I hope this was helpful. You can find all these codes and materials and the links in the description. So any comments are welcomed. So thank you for watching.